This is a video for AQA Further Pure Mathematics, section 2.7 of vectors, and this video looks at the perpendicular distance between two parallel lines. Well, here's an example of the sort of question you might face. We've got the lines L1 and L2 and their equations given by R1 and R2 at the top. The process is actually quite straightforward. What we do first of all is we can choose any point on one of the lines. So what I'm going to do is to choose point A by letting lambda equal to 0 in the second equation. So if lambda is equal to 0, this means that R2 is equal to 0, 1, 1, and that's the position vector of A. So A is the point 0, 1, 1. Now we're in a situation exactly the same as the previous video where we were finding the distance of a point from a line. What I'd like you to do then is to pause the video and try and work out for yourselves the distance using the methods that we looked at in the previous video. When you've done that, then you can come back to this and I will go through the solution. Right, once we've got our point A, then we can work out the position vector of P, OP, by using the R1 equation. So that's just 2 minus 3 mu minus 1 minus 4 mu and 1 plus 5 mu. The position vector of A is 0, 1, 1, so we can use that to get the vector for AP. AP is going to be equal to OP minus OA, the position vector of A. So in other words, we're just subtracting 0, 1 and 1 from the vector for OP. So that's going to be equal to 1 minus 3 mu minus 2 minus 4 mu and 5 mu. So this is AP, but we know that AP is perpendicular to line L1 and therefore AP dot product with the direction vector must be equal to 0. Well, this slide just shows what we've just done, but rather more neatly set out with the typeface. Once we've got to that point, then we need to write down an expression for AP.D, which is straightforward, so that AP.D equal to 0. If you write out that using the vectors above and then multiply out, you see that we get this expression, and that leads us to a value of mu being equal to negative 1 over 25. Once you've got the value of mu, as before, we simply substitute that into AP and find the length of AP using Pythagoras' theorem. So you can see that to find the distance between two parallel lines, once we've got this first point A by just choosing any point we like that's on the line, then it's exactly the same as the method that we used in the previous video. So this is the end of this video on the distance between two parallel lines, and in the final video of this series we'll be looking at how we calculate the distance between two lines that are skew lines.